All right, finally, we'll get this done here. It's my second try. Had a little goof up, and I've had trouble with it, but you guys should be able to get this pretty easy. It's a pretty easy lesson, okay? What we're going to do right now is we're going to note the difference. If you notice on your objective, the notes is entitled Finding the Particular Solution from the General Equation Given an Initial Condition, okay? And the objective of the lesson is, we've been finding antiderivatives, and we've always had that constant plus c at the end, okay? So what we're going to do today is we're going to find if you're given one particular piece of information called the initial condition, that you can find that c value. Okay, right now, and we'll see it here in a second, c value can be anything. All right, and we'll see and talk about that more. I know we've talked about it a little bit. We'll get into it more here in a second. So the very first example, let me let's see. I want to go over and load that. Okay, let me start with that first example. So we're given a derivative, d of y with respect to x. The derivative of y with respect to x is 2x. Now, this is called a differential equation. It's the equation of a derivative, differential equation. And we want to find out what y is. You've been doing this the past week. You've been doing it with simple integration. You've been doing it with u substitution. You've been taking what we call the integral. All right? So mathematically, here's how the math works in this. If we take and move the dx over, multiply both sides by dx, we get dy equals 2x dx. Okay? Now, that looks a little more familiar probably. If we then integrate both sides, we can do that. So it's just like adding 5 to both sides. We take the integral of both sides. We get the integral of dy equals the integral of 2x dx. Now, the integral of dy is really the integral of 1 dy. So I want to know what this is asking is, what did I take the derivative of with respect to y to get 1? And that answer is y, plus some constant. And what did I take the derivative of with respect to x to get 2x? And that answer is x squared. 2x squared over 2 is x squared plus some constant. We'll call it c2. And what we've been doing is we haven't really had this other side. We've just been doing this and getting x squared plus c. Well, we throw this y into it. Now we're going to get an equation. This is called the general equation. Y equals x squared. If I subtract c1 over c2, a constant minus another constant is just going to give me a constant. Okay? That's called the general solution. That's really what we've been doing it without this y for the last week. All right? So, that's the general solution with respect to y. Now, what I want you to do is I want you to let c equal -2. So I want you to graph y equals x squared minus 2. Y equals, I'm not going to write down, I got it up here on another board. Y equals x squared minus 2. I want you to graph y equals x squared plus 0, which is y equals x squared. I want you to graph y equals x squared plus 2. And I want you to graph y equals x squared plus 4. I got it there on your notes. Let c equal -2, 0, 2, and 4. Go ahead and do that. I'll give you a second to do that. 4 parabolas just starting at different values. The x value is going to start at is 0, but different starting values, different shifts up and down. Okay, so go ahead and graph those. And as you do that, I'm really fast. Maybe. Let me do this side first. Well, shoot, I'm just going to hold it. That's not working out very well. All right. By the time you get this done, that'll go on the blooper reel. All right. So you get these 4 graphed, and this is what you should get. So I'll give you a little more time. It's just 4 simple parabolas. First one's going to start at 0, -2. It's going to have that shift we studied, right left to 1 up 1, right left to 1 up 3, right left to 1 up 5. Next one's going to start at 0, 0, same shift. Next one's going to start at 0, 2, same shifts. Next one's going to start at 0, 4. Okay? So you get those 4 parabolas. They kind of run, I know parabolas aren't really parallel, but they kind of run parallel to each other. They're not going to intersect each other ever. Okay? Now, how many different values for c could we have? Well, c can be anything. We could do y equals x squared plus pi, and we could start at approximately 3.14. Okay? So that's the answer to that's infinite. We could have infinite c values. So how many different graphs could we draw? Well, the answer to that is infinite. We could have infinite parabolas, and they're all going to have this same look. Because the derivative of every one of these is the same. It's 2x. dy with respect to x is 2x. dy with respect to x is 2x. dy with respect to x is 2x on every one of those. Okay? So there's your 4 graphs. Hopefully you can see this okay. I know it's probably a little blurry, but you get the idea with your notes at home. All right? So now I say, all right, we're gonna introduce an initial condition. I'm gonna say I want the graph, I want the parabola that has the condition f of 2 equals 8. All right? F of 2 is equal to 8. That's called an initial condition. All it means is when x is 2, y is 8. Is that true on the blue one? When x is 2, is y 8? No, it's 2. How about on the orange? When x is 2, it's 4. How about on the purple? When x is 2, it's 6. How about on the green? When x is 2, y is 8. This is the only parabola that's going to go through 2, 8. So this, y equals x squared plus 4, is called the particular solution that goes through this, that has this condition met. Okay? So that's the one. That's the particular solution. Now, you're not going to graph these to get that every time. It's a lot simpler than that. Just showing you the graph to kind of guide you here. All you're going to do is you're going to say, all right, I know, kind of come over here. We're here. We got y equals x squared plus c. And I know that when I insert 2, I'm going to get 8 back. That's given to us. So that means when x is 2, y, f of 2, y is 8. So put that in your equation. 8 equals 2 squared plus c. And then it's very simple. You subtract 4, and you get 4 equals c. Then that goes right here, and your general solution, or your particular solution, is y equals x squared plus 4. Okay? Pretty simple. Should be pretty. That was a pretty simple example. All right. Let's go to the next example that you have. Get a little more challenging, little different notation. All right. So you got that down. Now you can watch it back. Okay. Now let's go to the next one. The next one I'm going to give you a little bit different notation. I'm going to tell you that f prime of x, okay, that's f prime, and you got it right here in your notes, equals 3x squared plus x minus 4. Find the general equation for f of x. So I want the general equation for f of x. Well, what am I telling you to do? I'm giving you the derivative, and I'm telling you to find what I had to take to get that derivative. Well, that's called the antiderivative, or the integral. Okay? So we do this, and we get 3 times x cubed over 3 plus x squared over 2 minus the antiderivative of each one of these, because it's plus and minus the antiderivative of 4 is 4x, because it's with respect to x, and plus this constant of integration. Okay? So what we're going to get is f of x equals x cubed plus 1/2 x squared minus 4x plus c. That is the general equation. All right, now let's find the particular equation, the particular solution. We have to be given a point. And it says 3, 1. 3, 1 is a point on this curve. So that means 3, 1 is a point on this curve. Okay. So all that means is that when x is 3, y is 1. Okay? So 1 equals 27 plus 9/2 minus 12 plus c. All right? So C is going to be a pretty big number, you know, because this is 1, and I'm getting a little low here. I'll put this down a second. Magic of okay. So 1 equals, let's get a common number. 54 halves plus 9 halves minus 24 halves plus C. So you guys can do this math. 1, I'm going to run out of room here. I got room still? 1 is 54 plus 9 is 63. 63 minus 24 is 39 halves. So 1 equals, hopefully I'm doing this right, 39 halves plus C. Okay, so C is going to equal 1 minus 39 halves, or 2 over 2 minus 39 halves. So C will equal negative 37 halves. Okay, now that's a little blurry, but you guys can hear me talk it out, and you guys can probably do this faster than I can. So the particular solution that goes to the point 31 is f of x equals, go back to this, x cubed plus 1/2 x squared minus 4x minus 37 halves. Just barely got it in there. Okay? All right, so that one wasn't bad. One more example. Call it a night here. Leave this up for a second. Make sure everybody's got it. Take a look at it. Okay? Now, one other thing, guys. Remember, this is the same as if you would have been given dy dx equals 3x squared plus x minus 4. And then you could have multiplied both sides by dx. You would have got 3x squared plus x minus 4 dx equals dy, and then you could have integrated both sides. So that's more of what we've seen lately. Okay? That's more of what we've seen lately. So that's the other way we've done it. All right? Okay. Now, let's go on to the last problem here. I'm going to save the back for tomorrow in class. We'll talk about it tomorrow because I need that graph and it didn't show up very well. So the last example, the second derivative of x is 3x squared. They tell me that f of 1 is 5 and f prime of 3 is 0. Find f of x. Solve for the differential equation. What that means is solve for f of x. So our final goal, okay, our final goal here is to find what f of x equals. That's what we're looking for. Okay? So, the second derivative of x is 3x squared. So the derivative, what do I have to take the derivative of to get the second derivative? Well, that's the first derivative. So the first derivative is the first derivative, to get the first derivative, I have to take the antiderivative of the second derivative. Well, that's going to be 3x cubed over 3. So x cubed plus some constant. Okay? Well, right here, I'm told that f prime of 3 is 0. So that means when I insert, so f prime of 3 is 0. So when I insert 0 here, or I'm sorry, when I insert 3 for x, I'm going to get 0 here. So 0 equals 3 cubed plus c. So 0 equals 27 plus a constant. So c in this constant is negative 27. All right? So now I know that f prime of x is x cubed plus 27. Or minus 27, excuse me. Plus negative 27 or minus 27. Okay? Once again, this fact, f prime of 3 is 0. I put 3 in for x. 3 cubed plus c equaled 0. All right? Now, the next part, I got to find f of x. That's my goal. Here, I'm going to move it down. I'll turn this here in a second. So my goal is to find f of x, like I said. When I'm done, I want to find f of x. So f of x, what do I know? I know the derivative of it. So f of x So I got to take the antiderivative of this to get f of x. So f of x is going to equal x to the 4th over 4 minus 27x plus c. And what do I know? I know when I put 1 in for x, when I put 1 in for x, f of 1 is 5. So I'll get 5 back, equals 1 to the 4th is 1 over 4, minus 27 times 1 is minus 27, plus c. So I'm kind of saving time. I put 1 in for both of those. So I put 5 in for this, and I put 1 in for this, and 1 in for this. Okay? And now it's just a matter of solving. Now, another thing you could do, guys, is if you don't want to mess with the fraction, you can multiply by 4 to both sides, and you'll get 20 equals 1 minus 108 plus 4c. Okay? So then 20, I'm going to come over here, 20 equals negative 107 plus 4c. I'll add 107, and I'll get 127 equals 4c. So c is 127 over 4. Great camera work. Okay, let me go. 5 equaled, this is what I had when I put in 5 for f of x and 1 for that. 5 equals 1/4 minus 27 plus c, and then I multiplied everything by 4 to get rid of that fraction, so I didn't have to mess with it the whole time. So my final answer for f of x is x to the 4th over 4 plus 27x, or minus 27x, plus 127 all over 4. Okay, well, we'll see how this worked out. Take a look at it, listen to it again. I know that it's a little blurry on the camera, so I'm sure it's going to be a little blurry at home, but I think you guys can do this work on your own. I think you've done very nice with the antiderivative. Tomorrow we'll look at some problems in class. All right? Have a good night.